Good morning, good afternoon, good night to everyone around the world from ISCT who's watching us. I have the privilege to be here in ISCT, the annual meeting in Paris, and joining me is Dr. Hannah Song. She is our top abstract award winner this year. Congratulations.
Thank you. Thanks.
So thanks for joining me. We're going to have a quick conversation before she rushes off to get her award. So I just wanted to first ask how you're enjoying Paris.
The meeting has been fabulous. So this is the third day, and I'm always surprised at how fast the meeting goes by, but it's just so jam-packed with events. So far I've gotten a little bit of taste of Paris for one of the sections we got to explore a little. They took us downtown, but I'm really hoping to explore Paris a little bit maybe tomorrow.
Oh, good. Okay. I hope you get to.
Yeah.
Okay. But you've had a good time at the meeting, like good scientific interaction so far?
Yeah, it's been fantastic. And this year, so my background is CAR-T.
Okay.
This is my second meeting at ISCT. The first meeting last year, I was really focused on pretty much exclusively the CAR-T track. And this year, I've joined a couple committees. I've met more people, and so I've kind of widened my scope this year, which I think has just been a lot more like engaging and exciting, and so I can still laser in on the important CAR-T stuff that I'm interested in and that we'll talk about, but this year I have had so many interesting discussions that really give me just a wider perspective on like where my piece fits into the field.
I love that. I think that is the beauty of the annual meeting and an annual meeting for a society like ISCT.
Exactly.
Just because people are doing such diverse work, but we're all sort of have a shared common interest, common purpose.
Exactly.
And so getting those different perspectives on your own work, and then there's always something to bring back to it.
Exactly, and dropping in, so there was great discussions on industry that as at the NIH, I haven't heard. It's really like academically focused, and so that's just been fantastic.
So yes, I did forget to say that at the outset that you are at the NIH. So
yep.
But your work there, that was what was featured in your abstract this year.
Exactly.
Right? So please tell, for those who unfortunately could not be here to see your award-winning abstract, could you give us like an elevator pitch summary of your work?
Yeah, so I'll just say, for the outset, so I'm in the product development group at the NIH, specifically at the clinical center. And so my research has been really focused on, the translation from the lab into that phase 1 early phase clinical trials. And so because NIH, has been working on it for, maybe 10, 12 years now, so we have a lot of tools, and we're starting to kind of integrate a lot of the clinical signals that we've seen into our thinking. And that's where that question that this research project came out of. So I guess the title, maybe I can't remember the title, it was pretty long, but it's the role of immunomagnetic selection, and specifically positive CD4, CD8 immunomagnetic selection, and how specifically that one step in a long CAR-T protocol can impact the function of your product. And so that's kind of I guess the quick pitch of the idea.
What was the
What's next?
What's the
right?
finding? Yeah.
Okay, so I guess
need to know.
Yeah. So the clinical motivation was that so upfront selection of T cells is really important. It defines the subsets of cells that are in your product, and you can do like a dynabead enrichment, which is CD3, CD28, streamlined. You can do CD3, you can do CD4, CD8 positive selection. Yep. You can do it single, so you could do a CD4 and a CD8, or you could do combined. So the question that we had was, because one of our manufacturing protocols started with a dynabead enrichment. Okay. So we use dynabeads to activate the T cells and expand them, and then sometimes the purities for a few patients just weren't good enough to infuse. And so we needed to add that 4/8 selection, but as soon as we did, we saw differences in the clinical outcomes of the patients. So everything in the manufacturing process was the same, but now we've included a 4-8 selection, and we didn't think that would change anything but the purity, but it changed the potency, we thought.
Okay. So was this like a clinical, was there some kind of clinical component here? I mean, same indication?
Yes, exactly. Oh, so to clarify, so this is a phase 1 trial. So the trial opened in 2014. So this is like, it's been a long time coming, right? And they treated a lot, I think maybe 15, 20 patients before they started to see those outliers that said, hey, you know, those outliers cause us a lot of trouble and we think we can do it better. And that was the CD4, CD8 selection. And the surprise was that in that, so we went to the FDA. This was before I joined, so it was my colleagues at the Center for Cellular Engineering. But they went to the FDA and said, we would like to introduce this manufacturing change. FDA gave, you know, approval because we had the data to support it. And so they stayed at the same dose level. At that time, they were on dose level 2.
Okay.
And all of a sudden saw more toxicities and de-escalated.
Wow.
And that was the genesis for the question. And so, yeah.
Has your work now prompted another design change in manufacturing?
Oh, yeah. So our central question was, should we use, if we can use a negative selection, because positive selection is ideal from a materials perspective because you have a CD4, a CD8 bead. A negative selection cocktail is inherently more complex and thus more costly. And so the question we were asking is, does it matter? And it does. It does in our CD22 CAR T cell. And that was the surprising finding. We actually saw differences just comparing a positive and a negative selection. We saw differences in our cytokine secretion and in the T cell subsets that came through.
Okay.
So it's a different product. It's very subtle, but I think it's important.
I'm just gonna have my mind spin. I think we could talk for an hour about how this impacts manufacturing, how it impacts clinical outcomes. I'm spinning from a manufacturing standpoint because we have also experienced issues around if you use beads to select the cells, that interferes with some other reagents that we're trying to use down the line.
100%.
Can we even move to a negative selection? Right? Is that the thing we should troubleshoot here, or?
Exactly.
Yeah.
And I think this study is one of the first to ask that question from a GMP perspective. Is it worth developing that type of reagent? And I think this shows that some of the things that we care about most, you know, toxicity, is impacted, and that kind of gives the clue that, yeah, you know, it's worth chasing if we can.
Chasing.
Yeah.
You think you guys will chase that problem? Or
I hope so.
Partner, like a clinical partner or commercial partnership, maybe?
Exactly.
Okay.
Yeah, that's what we're hoping to do, because I think we have a case where we can, you know, really see the differences, right? And so if we can implement that and make a product that is less toxic for patients, that would be super cool.
Right. I'm just thinking there's been so many times with things that I've heard at this conference so far.
Yeah.
Just around, you know, harnessing even that data, like the fact that you went and got the data to support a change in manufacturing that will support the clinical outcomes that we need.
Exactly.
Collecting data on each of these things to paint a complete picture of how vital this is for the manufacturing strategy.
Yes.
Right? I think this is a question and like an area of questions that people are grappling with now more than ever.
Exactly.
And so I just applaud you for chasing down that question and hopefully now, like, maybe you go find a collaborator here
yeah,
to help you chase down this question even more. I can't wait to see you do that.
Awesome.
Hopefully next year we'll hear more about that. But Hannah, thank you so much for joining me.
Thank you, Ashley.
Congratulations again.
I really appreciate it, and everyone at ISCT. I'm so grateful to be a member and to have opportunities like these. Thank you.
Of course. Well, thank you for joining us again, and everyone, enjoy the rest of the meeting, and we'll see you next year.